Hello to another programming session with a low-level vibe coder where we try to build an HTTP server from scratch in C with a little help of AI. So last time we implemented a very basic TCP server that returns a simple HTTP response with a message saying hello from server. And let's try to run it. Server is up and running, and we refresh. As you can see, it prints out a message that a client has connected, and we get the response in the browser. So things are working. So what are we going to work on today? Let's open the README. So we're at day 2. As you can see, what is it called? Copilot already has a good suggestion here. We could do this. My autocomplete isn't working for some reason. Yeah, it's kind of bugged in README files. I need to fix it, but this will do for now. So this is something good that we could work on today. Serve static files. Yeah, maybe not today. I mean, one other good thing that we could work on is trying to handle requests in parallel. But I think I'll leave this till the very end. Once we have like everything working. So like the point that I want to reach is like I want to build something similar to those libraries, like for example Express in Node.js, or I don't know, Fast API in Python, where you can just do something like this, app.get, yeah, as you can see, and you specify a handler and just and make all of that work basically. So I want to get there. So let's just start working on handling requests today. So when a request comes in, so right now we're not actually, I think, reading anything from the client. When a client connects, it sends a request. If we open the browser here, let's hit inspect, do this, go to network. So it's not running. Sorry. Okay. Oops. Whoops. And we run the server. Yeah, as you can see right now, it's also like the browser is requesting the favicon, which is the icon that's displayed here. And we're basically returning the same response for everything. Anyways, let's look at the request. Can we view it? Yeah. So this is what the request looks like. This is what the browser sends to our server every time we hit refresh. So basically we need to parse all of this. Like the method, this is the method, and then there's the path name. So for example, if I do something like this, and go here, request headers. Oh, why is it complaining now? What? It shouldn't be doing this. Oh, now it's working, I guess. Yeah, something weird was happening. Anyways, we hit draw. Yeah, as you can see, the path name is here now. HTTP version, and then all of this is basically the headers that the browser sends, and we need to parse all of these and maybe like bundle them in a hash map or something. So this is what we'll try to do today. Let's go to the code. So I'm gonna start by adding a request.h file and request.c. Request.h is gonna be I forgot how to do this. Basically in header files you need to add, I think it's called a directive. so that the header file doesn't get included more than once. If not defined, I see. I think so. Request H, we're define request H, and then end if. I think this is it. Let's try to build the struct first. So a method. I'm thinking maybe we should create an enum for the method. But let's ask ChatGPT here. Does HTTP support custom methods? Yeah, take your time. Yeah, then we can't use an enum. And I think this can't be fixed size. It has to be dynamic size because we don't know how long the method name is going to be, or the method string. Oh, I remember, actually, I remember asking Claude here about questions. Whoops. Yeah, I think it's this. Oh my god. Yeah. I sent this last time. I need to save it. We have the path name, HTTP version. I don't care about that right now. We're only gonna support 1.1. Or actually, maybe we need to parse it actually. Just in case we receive requests that are not 1.1, so we could like reject them. What else? We have the headers. And for that, we're gonna need the hash map implementation, which I need to find. Why is this not working? Cool. So what did I want to ask? I forgot already. Very cool. Yeah, I think we also need a connection header file, just so we could have a struct for the connection that we could just pass around functions. And if and type def struct. It's not going to be HTTP requests. It's going to be non. I'm just going to prefix everything with non-HTTP, non-UDP, HTTP. Not request, connection. Yeah, we're going to have the file descriptor. That's good to have. Client IP. Client port, sure. Anything else you want to suggest? I think that should be enough. So here, yeah, I'm thinking about doing something. So basically, in order to do like all of this request parsing stuff, we need to do a lot of like memory allocation. Like for example, we have to do a malloc call for each one of these, and we might have like intermediate variables that we need to store things in. So it's gonna be a lot of memory allocation, which we have to worry about freeing later on, so we don't cause memory leaks. And a while ago, I worked on something called like a C project, basically called an arena allocator, where basically you write your own memory allocator called an arena allocator. And the way that it works is that you basically start by allocating like a big chunk of memory, like something like 4 kilobytes or something. And then that chunk of memory, you could later use to allocate like you basically allocate sections from it to like each variable that you want to use within like a lifetime or a specific context. And then later, like let's say you do like 50 allocation calls on your arena. The cool thing about it is that you don't have to like track all of like each allocation call. At the end, once like you're done with everything, you can just call arena clear, and it will basically clear that entire region of memory. And yeah, this makes things a lot simpler. I mean, yeah, sure, you could say that it uses more memory because usually when you call malloc and you're done with a variable, you immediately free it. But memory isn't like a big issue here, and we're only dealing with like small strings. So I don't think it's going to be a big deal. And I do have my own implementation of it here, I think. Yeah, I've already opened it before. So I'm just going to go here, copy the file. Arena.h, or did I copy the C? Yeah. Let's copy the header file as well. So instead of it being arena v0, it's going to be just arena. And we're going to go here and do the same thing. Anything else? No, these are... Now, what's the C header file for uint8? I don't really know. Yeah, this is going to be like this. Oh, okay, that fixed it. I think it's stdint, yeah, which we already have. So yeah, as you can see here, we have arena create. It creates an arena, like one malloc call. And then we have a custom allocate function that we use for things like variables. And once we're done, we can either destroy the arena completely, so we can't use it anymore, or we could just reset it and reuse it for more things. And yeah, basically an arena allocator is useful for things like, for example, here, a client connects, we have to do parsing, we have to prepare the response, do some maybe like processing on the request, and then we send them the response, right? And all of this process requires, you know, lots of variables which require memory allocation and freeing and all of that. But at the end, once like the request lifecycle is over and we send a response to the client, then like basically everything that happened since we received the request, we can just get rid of. So this is why using an arena allocator is like, it's basically a good use case for this type of allocator here, I think. I mean, I don't know much about allocators. I've only written an arena allocator. I think there are other types which may be better in this use case, but I think this will work for now. So here, we basically create an arena create, and we have an arena, which we need to pass around functions. And I'm thinking that maybe we could put it in the connection here, so that arena, or it's arena, and we include arena.h. Now let's have a function here. How do you define a function? So it's going to be this, create connection, Maybe it's not a good idea to do this. I'm just gonna do this instead. Maybe I should also specify a name here. Create HTTP connection, and it's gonna receive a socket, client IP, client port, and the most important is the arena. And what it's gonna do is basically this. HTTP connection. So do we have the, I don't think we have the client IP as a string, so we need to convert it. Maybe we should not store it as a string. We have client address dot syn family, syn port. This is just a number. I think it's this. What does the struct look like? Oh yeah, it's just a UN32. Let's do this. Let's just use the struct that they're using. Or the type def. Yeah. Good idea. Client IP. Okay. This way, we don't have to worry about it being a pointer anymore. And we just do client IP. And why is this complaining? Oh. Wait, you have to do it in the same order? Or is this just a warning? I wonder if it does anything. And we need to take this. Oh, I just realized that I'm writing code in a header file. So connection.h, and we delete this, add a semicolon, and we're good to go. Oh, I think there's a, oh, yeah, that works. That was kind of weird. So now here we can say HTTP connection, create connection, and we basically pass in everything. And why are we doing this? Network to host order. Let's ask ChatGPT. Or maybe we could look at the man page. I think it's man 3. N to HS. Function converts unsigned short integer from network byte order to host byte order. Do we need to convert it? Yeah, I think it might make sense to, since we're gonna be using it. But we might, like later, try to print it. Actually, I wonder how to convert. What is it called again? In address T and C to a string that can be printed. I think it might still be good. Now let's just keep it as network byte order, just in case we need to use functions like this. so that we don't have to convert it back. It's good to have it in big endian, which is network byte order. Okay, let's continue. Where were we? Cool, we're not using the connection, which is... Wait, why are we not getting warnings? One sec. Let me exit. Do we not have compile commands? Oh, we don't. So we're gonna use bear here and just basically, let's do make clean first. Make clean again. And we're gonna do bear make. This basically generates compile commands, you know, like the commands that we use to compile our C code so that the editor can provide like the proper messages and highlights and stuff like that. So now if we go back, go to main, yeah, as you can see, it now says that, you know, the exact same warnings and errors that you see when compiling, you'll see in the, we'll be able to see in the editor as well. Request.c. Okay, we're done with connection here. We're gonna need to grab a hash map implementation in a minute for storing the headers. But let's try to implement a basic parser for these things first. Parse HTTP request. Yeah, exactly. It's not going to take in an arena. However, it will take in a connection. Unknown type. Why? Why is it unknown? Let's include request.h. I wonder why this is complaining. Let's try to compile. Maybe it's because of the compile commands. It works fine. I'll update them in a second. Let's just copy this, go here, do this. So yeah, I think we need to receive data from our client here. And let's ask ChatGPT. If I have a TCP server and want to receive data from a connected socket, how big should my read buffer be? And how can I read a large chunk of data? Let's see. Common buffer sizes, reading from a socket. If you expect arbitrary length data, allocating a dynamic buffer. What if how would I handle, or how would I make my server be able to handle really large TCP payloads? Should it stream the, or actually, well, existing HTTP libraries, Node.js and Python, for example, crash if you send them really big payload. Maybe 5 gigabytes or something. Yeah, we need to process data incrementally, which I already understand. I see. So we should probably only read... I mean, we could worry about this later, but we should, like for now, we should probably only read the headers. Okay, this might be a good question to ask to Claude. How big can HTTP, the HTTP header section be? Servers need to impose limits to protect against malicious or broken clients. But it warns you need to set some limit. Okay. Four kilobytes to 8 kilobytes for headers. Yeah, we're gonna have to do some very complex string parsing here. We're not gonna do this. And we're also not gonna do this. Yeah, let's see here. What's the best way to, I guess, instead of passing like the entire thing as a character pointer, I want to pass it in as a stream so that this like request function actually is responsible for reading only the headers. So I'm thinking about designing a request parser in C. And I'm wondering whether the parse function should accept the file descriptor, try to parse the HTTP version, path name, and headers, put them in a struct, and then stop. But save a position in the stream maybe? Then stop and leave the rest of the stream on the file descriptor so that it can be used later to read the body if needed. I need something to track how much has been read from a file descriptor. Or I guess what's the best way to implement this? Yeah, I thought this would be easy. Now we're getting into the real difficult stuff, I think, early on. Read from the socket until you find the end of headers. That's correct. Parse everything before the delimiter. Leave any body bytes that come after. Exactly. But file descriptors have a key limitation. You can't unread data. Yeah, I was thinking about that. Because like, let's say you have a buffer of, I don't know, size, let's say 1 kilobyte. And you read 1 kilobyte at a time. And let's say that your headers, the size of your headers are like 1500. So basically you read in the first chunk. That's basically this minus this. And you're left with 476 bytes, which you need to read in the next iteration. So you read another 1 kilobyte. But you've already read past the delimiter of, or like the past the header section, and you read into the body. And this is a problem because once you read data, as they say here, you can't unread it. So in case you want to pass that data, or basically pass the files descriptor into a function that reads the body, you've already like read a chunk of the body. You already ate that chunk. So that function, when it tries to read the body, it will get missing data from the beginning, depending on how big your buffer is. They're consumed from the kernel buffer. Why not parse directly from file descriptor? I mean, yeah, I understand why it's bad. Read 1 byte at a time. Yeah, we can't really do that. That's extremely inefficient. Because like every time you call receive, it's basically a system call. You're asking the kernel to read data for you from a socket. And syscalls are a bit expensive if you do too much of them. Works, but extremely inefficient. Yeah, as you can see, that's 8,000 syscalls. Now you're a different problem. What if those include headers and part of the body? Yeah, we already discussed this. Read buffer with position tracking. Many servers use a connection buffer that reads ahead, and the parser tracks its position. Oh, yeah, I think it might make sense to implement like some sort of reader here. Reads chunks from socket into the buffer using receive. Parser operates on the buffer, not the file descriptor directly. Track a position. When the headers end, position points to where the body starts. For body reading, continue from that position. Yeah, I think this is what some implementations I've already seen already do. Like in Rust, for example, I think they have something like this. Parse in place with state machine. Read data as it arrives and parse incrementally. Adds data, and the parser resumes from where it left off. Wait, how does this work? Read all the headers first. Keep reading until you see accumulating into a growing buffer. What if headers never end? Yeah. Slow Loris attack. The double CRLF problem. How do you know when to stop reading? You need to scan for, but it might not arrive in one receive call. Oh, true. Oh, that's a good point here. I didn't think about this. Keep reading until it finds the delimiter. Remember where the delimiter was, not discard the bytes after it. We've already built this. Read buffer used. I mean, we could do this. So I was thinking, I think we should just create a buffer interface here that does things for us. And let's open Claude, not here actually. Let's go here, open Claude. Let's ask the same question. Or actually, never mind. I'm just gonna create a buffer interface. If not defined, buffer.h and if. So we basically create a buffer. Let's do a type def. Should it be called buffer? Buffer reader maybe? Capacity, length, and position. Yeah, this looks right. Is it better to use size_t or int when dealing with sizes and positions of a buffer? So we basically need a function to create buffer reader. Let's just use ints for now. So we create a buffer reader, and then we have a function. I like to do this. Buffer reader read. And it takes in a buffer reader, a destination, and number of bytes to read. That looks about right. Let's have also buffer reader destroy. Let's pass in pointers here. Save changes, yes. Include buffer.h. So this is not going to take it in. Like the actual buffer is going to create it. We're going to call malloc from standard library. It's not going to be a character. Let's just use uint80. We don't have to cast it. Size of a byte times capacity. What's the difference between capacity and length? Well, length and position. Capacity is the max. Length, in case, yeah, it's just the length of the data inside. I think, right? Yeah, we don't have to pass it in either. We just need capacity. Just to make things simpler, I'll also remove this and just define it here. And let's do 4 kilobytes. Capacity, length is going to be 0 initially. This is going to be a uint8 t. This looks about right. Okay. So where is this reading from? It needs to take in a file descriptor as well. Maybe we should call it fd buffer reader. The rename didn't work for some reason. And it's gonna have the file descriptor. These are gonna be prefixed as well with file descriptor, and I'm gonna add int file descriptor here. I'm gonna have this, and let's write this ourselves. So what will read do? It's gonna take in, yeah, this looks right. So how is this gonna work? Let's not cheat here. I want to implement this myself. Nope. I keep pressing tab, dude. Like, what is this? stop. Can I disable it? Copilot. Chat open, prompts, chat reset. Bytes to read. I guess the first thing that we need to do is, let's do this. While reader length minus reader dot position, I don't care about all of this, is less than bytes to read. I could do this like in a multi-step process, but I want to do it like in a big, you know, single while loop. So the first thing we're gonna do is, okay, so we have one thing. How do we know that we've reached the end when we read? We know that we've reached the end if, so while bytes to read is bigger than 0, and we have not reached the end. This is not going to be a return of file descriptor buffer reader. It's going to return how many bytes have been read. Because when you call this function, you may ask for, like, for example, for 100 bytes, but it may return less in case there's no more data to read. So it's going to return an int. And this one is going to be void. It won't return anything. And reader position is bigger than reader.length. Let's start with this. If reader.position is bigger than or equal to reader.length, if the position is bigger than or equal to the capacity, then that means we've reached the end. Then we need to read more. If bytes read is less than or equal to 0, in this case, that means we've reached EOF. And I think we just break, right? Oh, it could be an error as well. Yeah, bytes available is exactly. If bytes to read, we basically take the min here. Let's do a mem copy. Destination. Source is going to be we're going to have an aids file to have that has helper functions to aid the developer. So basically define aids h, if not defined, and if. Can you give me generic min max functions or C define or macros, I guess. See. Wait, what is that? What's that? Thumbs up. Let's just use these for now. Bytes to read and bytes to copy. Why is it conflicting types? Oh. Buffer, if buffer is empty, try to fill it. We fill the buffer, we copy the data, then what? Here we don't actually break. I guess we do bytes read. Let's man read. On success, a number of bytes read is returned. The 0 indicates end of file. The file position is advanced. Oh. So 0 indicates end of file. It is not an error if this number is smaller than the number of bytes requested. Well, because data may not be available yet. We need to add an extra, maybe bool here. EOF? I don't think so. What should we call it? Reached. So if bytes read is less than 0, we just return -1. That means error. Bytes read is 0, basically reached end of file. And we break. And here we can check, I guess. Yes. And this starts as false. There's still one more thing that we haven't done, I think. So bytes read, but we haven't updated reader position. So we advance the position, and in case bytes to read is already 0, then we just return. Otherwise, we loop one more time. If there's still more data, and we haven't like read everything yet, this will be just skipped, I think. I think length is kind of useless here, no? No, it's not. Never mind. We copy. We update the position. Length we're not supposed to touch, I think. Capacity we're not supposed to touch. But if we have a big number specified for bytes to read, then it will read the first time, it will copy the data, then it will go back here, check, reader dot position is bigger than reader capacity, read more data, copy more data. I think this should be it over here. And we can maybe test this. FD buffer reader, client file descriptor, and then we do FD buffer reader read. Wait, why is this size of buffer -1? Why is it -1? This is incorrect. Let's make the buffer like really big. 80K. And let's try to printf. Let's see what happens. Let's do bear make first. We haven't done that in a bit. Okay. Oh, make is also complaining. What? Unknown type HTTP connection. Oh man, it's connection H. I should fix it. Make clean and make. Control reaches end of non-void function. Is that a request? This is fine. For now. Let's do bear make. Make clean and bear make. We run the server. We refresh. It is getting stuck. Why is that? Oh, we're stuck in a loop, I think. We need to do bytes to read. They should do it. We make and run. Refresh. Still the same issue. Let's printf here. Copied 0 bytes. How did we end up here? I wonder. Potato. Let's print reader position and reader capacity, or not capacity, length. That's pretty nice. So position is 0, length is 0. Why is that? Let's do red bytes. Oh. I think it should be like this. There we go. It works. Oh shit. Address already in use. I've run across this before. I think it's because when binding server socket, TCP server socket in C, I get a bind failed address already in use. How to fix? I think we have to specify a flag or something. Man, ChatGPT is really slow. Means that port you're trying to bind is still in use or stuck in time wait. It doesn't disappear immediately. Yeah, the connection often lingers in the time wait state for up to 1 to 2 minutes to ensure all delayed packets are safely discarded. So if you restart your server quickly, bind fails to because the port is still considered in use by the kernel. So I think we need to do this. Right? Yeah. Let's fix. This is before calling bind, I believe. Yeah. It has to be here. Server file descriptor. Now if you would do this, it works. So the issue is that it's not printing the request. And that's because when you use printf, printf also has buffering. So when you use it, it will buffer it. I think the kernel decides when to flush all the printfs that you have in your code to the console, not you. But if you want to force that, you can do this. Flush standard out. And I usually try to, I usually like to have a function for this. If we go to our aids here, and we define a debug, debug print. It doesn't want to autocomplete. Come on. Come on, Copilot. Debug print enabled. Define debug print. Okay, sure. Debug print enabled fprintf. We print to standard out, standard error. I mean, sure. Wait, why is it in a while loop? I wonder. Why is this macro in a while loop? What's the purpose? Suppose you wrote this and use it like this. This expands to this. That second if inside the macro steals the else. Oh, it does. I see. So this wraps it in like a block. That's pretty smart. Anyways, let's do this now. My debug print. Yeah, but it doesn't flush, dude. What is this? Do I have to flush the toilet? The standard error. Come on, come on. Usually no, but sometimes yes. Flushes automatically. Oh, I see. Okay, that's good to know. I didn't know that. So we don't have to flush. We just have to replace these. Printf. Debug print. Let's go back. Now, if we refresh, we're still getting the same issue. So it's not flushing, dude. Come on. I'm just gonna call it flush. Rebuild. Wait, it's not. The flush is not the problem here. We're getting stuck here. For some reason. Let's go back to our buffer. Something extremely wrong is happening here. It's getting stuck somewhere. Let's do debug print. So red bytes, then we have potato, and then it breaks. It returns. I mean, or at least it's supposed to return. And then we have this line, but it's not being printed. I see what's happening here. But it's supposed to break, no? Let's debug print bytes to read. After reading. Still have this much that we need to read. So is that making us be stuck in the loop? But we're not getting like repeated prints. I wonder why. Why do we get stuck? Is it because of the read? Is this gonna block? If the file descriptor refers to a file other than a socket. Wait, did it already return 0? I wonder. Let's do this. Reached EOF. It did not reach EOF. We read a number of bytes. Read return. This is just an integer. I think read is blocking, that's the issue. But why? Oh, I see what the problem is. When using read in C, it's getting stuck because it's blocking. How do I know when to stop reading? Oh man, I think I need to keep reading or block. So for example, if I just receive a request, initially we have the status line. So we read that, and then we read the headers, and we basically block and keep reading until we get the /r/n like twice to indicate the end of the headers section. So once that's done, and in the header we have content length. Okay, so this has to be conditional basically. Like whether we try to read more or not. And it's kind of a problem. I think it's because the browser doesn't close the connection and read will wait, expecting more data to come when the request has already been completely sent. Oh man, this is gonna require rewriting or maybe thinking of a different approach. Let's see. Defaults to persistent connections. Browser doesn't close the connection after sending a request because it expects to reuse it. So read waits for more data that never comes. How to know when a request is complete? Read until you see this. That's the complete request. For requests with the body. Okay, so the parser I think has to be part of the, what is it called, the reader, because we need to inspect the data and make sure that we've received the end of the header section. It can't be separate, so we have to remove all of this. You must parse the headers first to determine the body length. Content length header. Read incrementally into a buffer. Don't read everything at once. Yeah, I think we have to rewrite this. So what we need to do is basically we need to parse until we find an /r/n. But also when we parse the body, we do know the length. So I think for the body, we can just use this function because we already have bytes to read, because that would be in HTTP, basically when like for the body, you have to specify the length in the headers. And you pass a header called content length, and it's the number of bytes that in the body basically. So for that we can use this function, but that will come later. We won't add any body parsing until very later on. But initially we need another function, which is it's gonna read until is what it's going to be called. It's going to take a reader, a destination, and it's going to take a delimiter, but the delimiter isn't a byte though. It's going to be a character array. What is it going to be called? Delimiter. And yeah, it's going to take an int max bytes as well, because we still want to limit the headers. Since we're passing in this like destination buffer, we don't want to overflow it in case, like, you know, somebody tries to send in a header that's like, I don't know, 10,000 characters long. We need to have a limit on that. So if the limit is reached, we should basically throw an error and just, reject the request. Anyways, let's try to do this. So I don't want to use, actually, let me do this real quick. And then, we're gonna go to new Vim Copilot. I'm just gonna turn this off. I don't want Copilot to basically give me the solutions, or should we just keep it? I don't know. Let's just keep it. Why not? But I'm not gonna use its code, or maybe we could use some of it. So bytes read, I guess. Yeah, we need to track that. It's basically gonna be similar to this. So we're gonna pass in a reader, and if we reach the end of file, we're gonna return 0. So we basically read nothing. While bytes to read, that's not how it's gonna be. How do I read? No. Ooh, I think here's what we're gonna do. We're gonna have a variable delimiter position. It's gonna be 0, and we're gonna have delimiter length, which is gonna be that. While, yeah, bytes read, let's copy from this basically. Wait, what did Copilot suggest? Is less than max bytes? I mean, either works. Let's not do this. If reader dot position. Okay, what does this mean? Reader position is bigger than or equal to reader dot length. I think that that means we exhausted our buffer reader buffer, and we basically try to read more. If it's less than 0, that means there's an error. If it's 0, end of file. And we update these. Yeah, we might need to move this into a function. Move this to a helper function. What then? Are we copying to this? Here we are. Let's copy this and update. So, bytes available. So we need to check the delimiter here. But what's the best way to do this? So I think what we can do is we can write to destination anyways. So yeah, bytes available, we need that part. Bytes to copy is going to be a min. Bytes available. Yeah, we're not going to have bytes to copy here. Oh, actually, I'm not going to do this. We're going to do max bytes is bigger than 0. And here we're going to do max bytes. Oh, actually, we need to throw an error if we basically reached max bytes without finding the delimiter. So this is not going to work. So we need to do a mem copy of bytes available. Or maybe let's not do a mem copy. Let's just copy manually in like a for loop, because we need to check the delimiter as well. Now let's comment these out for a minute. Let's remove the debugs. I don't think we need them. Yeah, I'm thinking about adding tests for these two functions here, just so we avoid like potential, like, you know, difficult bugs later on. So it's not going to be bytes to copy. It's basically going to be this. So what are we going to do here? While, or let's do for actually. We're not going to have a counter variable. It's going to be reader position is less than reader length. And here we're going to basically do, yeah, reader position. I don't care about this. Like, is there a way to only make Copilot autocomplete like one line of code instead of everything? Copilot new then. Is this Alt Control right? Oh, it is. Okay, that works. It's not the best shortcut, but it works. So destination bytes red, which is going to start from 0 plus equal. Dude. Reader buffer, reader position. This looks right. Yeah, but we're not going to copy, right? There's something that I haven't thought about. So let's say that we have this delimiter, which is 2 characters. So on the first iteration, we're going to find the /r, which we're going to copy to destination. And then on the next iteration, we're going to find the next part of the delimiter, the \n. And then we're going to stop. But I'm thinking maybe we should not copy the delimiter into the destination buffer. So what we need to do is basically undo the copying. Basically, when we hit the end of the delimiter and we stop copying, we uncopy delimiter.length, the length of the delimiter -1, I think, is what we need to do. We'll figure it out in a second. Max bytes, yeah, that's going to be -1. Copy until buffer is exhausted or delimiter is found, yeah. These comments are good. Check for delimiter match. Okay, let's see if this makes sense. Or maybe, yeah, let's do the delimiter check after copying. So even if we copy like one more character, that's fine. And we can just then uncopy the entire thing. So destination bytes red -1. Or maybe we could do this down here, so we don't have to do the -1. Is the delimiter position. If it is equal, we basically add +1. If delimiter position is the delimiter length, why are we doing this? Reader position +1. Oh, because we're returning early. And we basically delimiter found return early. There we do bytes red +1, max bytes -1. Else, if it doesn't match, then the delimiter position is going to flip back to 0. And let's add this helper function. No, we're not going to destroy. Oh, we have a destroy, don't we? Oh, we do. Let's add it, yeah. Which basically just frees it. Cool. Cool. Bytes available, we don't really care about. So if the delimiter is found, we return early and we return bytes read. Yeah, but that's not what I want to do. Here, we do bytes read minus equals delimiter length minus 1. Is that how it works? So we read 1 byte. This is going to be 0, 0. Yeah, I guess. Yeah, that makes sense. Actually, maybe bytes read we can do here. Yeah, I think this makes... Yeah, we need to be careful about these things. Delimiter position, bytes read now. Yeah, can just be minus equals delimiter length. Actually, we don't even have to uncopy. Since we're returning the number of bytes read, then the caller has to worry about not reading after the number of bytes that we read. So even if we like overcopy a little bit, it's just going to be garbage data that the caller should not try to read. The buffer reader consume or fill. No, this is incorrect, my friend. This is not going to be break. And this is going to be return 0. And let's do int here. So now we can do this. Nope. We're going to use this function. If bytes remaining, yeah, is less than 0, then error. If bytes remaining equals 0, yeah. Let's do the same thing here. Okay. So bytes read is going to be minus delimiter length. I kind of want to test this thing. Can you give me a C panic macro that prints a message and exits? Where's my 8s file? This is gonna go here. We're gonna go to main. We already have 8s here. Let's move these down here. And I'm just gonna do panic. Testing. Just so we can test this function here. So let's see what we're gonna do. So if the buffer reader, we're gonna create, oh, we need to pass in a file descriptor. That's not good. Okay, let's create a test file maybe somewhere. How is this gonna work? Let's add it here. Test HTTP request. .txt. What is it gonna have? Can you give me an example of a simple HTTP request with a simple body with a message? With a message, hello world. You can add a few headers of varying lengths. That's good. I wonder if the /r, /r, /n is, they're not visible. Let's do xdd. Where is it? Oh, it's xxd, sorry. Didn't print anything. Oh, we didn't save. Host. Yeah. Can you add the to your real, an actual share post? Yeah, that's what I want. Otherwise, it's not gonna work. ASCII table. I just want to validate that the \n is actually, I think it's 6e, right? 6e. There's lowercase n. Ooh, that's not good. What about 5c? It's \. No, it added them as two separate characters. That's not what I wanted. Can you give it to me in binary? Raw binary file, which I can download. I mean, I could just go over and add them manually, but I don't want to do that. And I'm not sure what the best way to do this is. Okay, so let's do this. Downloads, what is it called again? HTTP request .bin. And let's just copy it here and remove this. Let's do an XDD again. I think this should work now. It's 0D, 0A. Let's check. 0D. Oops. 0D is carriage return, \r, and 0N. Or no, it wasn't N. It was A. And a line feed. Yeah, that looks right. And now we basically need. So this buffer reader accepts a file descriptor, and the way things work in Linux is that, you know, everything is a file. I think I might be wrong on this, but basically everything is a file, even like network sockets. So you can treat network sockets and like regular files as the same thing, and you can basically read data from them with the same function, like with one function I meant. So can you give me simple C code that reads a file? It's just f open. I just want this part. So file name is gonna be not like this. It's gonna be this, but it's gonna be in the same directory because that's where we're running the code from. Yeah, if it failed, it failed. Then we pass in the file descriptor. Wait, what is file? Struct IO file. What is that? What is the file struct? I haven't seen this before. I thought they would return a file descriptor. Or hidden in the C library implementation. What if I want a file descriptor? Okay, so we can get it from there. Open a file directory directly as a file descriptor. Okay, yeah, let's do that. And it's just gonna be fd. Open is not there. Is it uni std? We already have this. It's not. I think it's the other one. I hope we have this. Okay, oh, read only. Sys uni std is just uni std. Okay. So we make a server. It panicked, which is good. So now let's do this. Fd, yeah, let's allocate a buffer of 10 actually. I just want to test a few things first. Not read until. We want to test the first function. Or let's just test read until. That's what we care about right now. So a buffer of 10, size of buffer. That looks right. And one cool thing we can do here is, I hope I have nodemon. I don't. Oh. It's basically a script that's, meant to be used with JavaScript files that reloads, basically launches or runs your code every time a file changes. And what we can do here is we can do nodemon exec. We can make it run this command and server every time the server changes. Or no, that's not how it works. Sleep. Is there a sleep command? Yeah. Okay, so let's do this again. Nodemon exec make. We're gonna sleep for like half a second to wait for the code to compile. And then we're gonna run server. And we're gonna listen for C files. Yeah, but since we're exiting with 1, it will exit the process. Nodemon don't exit on, I think it was 1, right? Nodemon crashes, process returns 1. Yeah, there was a way to ignore the return, what's it called? The return code, I think, of the process. But I don't know how. Okay, or true. Yeah, that makes sense. See, now it works. Then we have the limiter. And we have max bytes. What is it complaining about? Oh, that one. That works. And let's print, what is it called, debug? Read 171 bytes. That's not good. That is not good at all. If max bytes is bigger than 1. It's because of this, I think. We need to check here as well. Is bigger than 0. Okay, that's more like it. And let's debug print. We basically read post exam 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It read exactly 10 bytes. Yeah, we need a good way to communicate back from this function. Whether it had reached the max bytes or whether it reached the delimiter. I wonder how. I guess let's ask Claude here. I want this function to have a return type that communicates all of the following. The number of bytes read in case the delimiter is reached, whether max bytes was reached, which is considered an error, whether reading from the file descriptor failed, which returns -1, and what's the last thing? I think that's all, right? Yeah. I mean, we could have a struct. Not a big fan. Output parameters. Bytes read. I prefer this for now. I'm just gonna be lazy. Max bytes limit exceeded. So here we're gonna do -2, I think. Maybe we should still return the number of bytes read. We can just update this later. Because I'm thinking that maybe, like, even if we reached the max bytes, what if the caller still wants to read the data that we, fed into destination here? But I don't think we have a use case for that right now, so we don't have to worry about it. Our use case, if we don't find the delimiter, then we just don't do anything. We just throw everything in the garbage and reject the request. So we return -2. Here we have error reading. Wait, this is bad. I think if we reached end of file, that's also considered an error because we're trying to find a delimiter. So we return -2 from here. Okay, I think that looks good. Let's try this. So now it returns -2 correctly. Let's initialize our buffer with zeros just for now. And what if you do 100? It should read the entire status line, which it did not. That's not good. It did not stop. If we do 1,000, oh, it's because of this. See, now it works. Amazing. And let's see the length of this. If you do node, whoops, do length, it's 27. Very cool. Okay, I want to test something else. Let's try to look for this. So it read all of that. Then it, I think, yeah, it basically reached the buffer. What's it called? The max bytes here. But if, let's say we make it like really big, it's gonna reach end of file and not find anything. And it's also gonna return -2. Yeah, I think this works. Hopefully we don't run into bugs. I'm just gonna keep this code here for now.